All right, so ladies and gentlemen, we're going to finish up Chapter 10 with the Chapter 10 for notes. We're doing the old hyperbola. And if you take a look at our goal today, it says find the equation of hyperbola. It's going to be so easy. I'm going to show you how to do it. You're going, man, this is easy, Mr. Gotcha. And then we're going to graph these things. Again, there's going to be two different types. The first one I'm going to show you is going to be opening left and right, and the second will be up and down. All right? Last but not least, we're going to start moving these things around. We're working with these guys where your center is at H and K, so they're not always at the origin. They start moving. That'll be super easy. By definition, it says the hyperbola is a collection of points in the plane. The difference of whose distances from two fixed points called foci is constant. So if I have a point on here, and I find the distance and I subtract, those will always be the same value. The idea is this is c squared, this is a squared. It will always equal to b squared. Okay, c squared minus a squared is equal to b squared, or vice versa. So eventually we're going to be talking about p frags here. Okay, it kind of looks like a right triangle. So as we take a look, we got the old hyperbola here. Let me get it all on here. We got to just bring it down just a touch. The old hyperbola. All right. So here's the two that we're going to be dealing with. The first one is opening side to side. The second one is opening up and down. Now, before we talk about the differences between the two, let's talk about just look at these formulas and compare them to what we just learned with the ellipse. Okay? There's one subtle change between the hyperbola and the ellipse. Does anybody see the little change, Molly? The square, so A's are squared, so they're both squared in both, yep. So A is squared and B is squared. But there's one subtle little change with the ellipse and the hyperbola. Nick? Negative. Yeah, so it's a fraction minus a fraction this time. In ellipses, it was a fraction plus a fraction. Okay, so that's the big change here, is that there's a minus in between. So if there's a minus in between, now I know I'm graphing a hyperbola versus an ellipse. Okay, so if you see a minus, that's hyperbola. If you see a plus in between, now we got an ellipse. Okay, now this one opens side to side, this one opens up and down. Right? If I take a look at the two formulas, there's some changes. Landon, do you see any changes there?
When a squared is under x, it goes left and right, and when it's under y, it goes up and down.
Okay, so we look at the a squared. Now, before, a squared was always the big guy. Well, now a is no longer the big guy, it's actually the first guy. So a is first. A could be smaller than b. That's okay. A is always the first guy, and B is always the second guy. Okay? So, you're right that A is underneath the X, and A is underneath the Y, and that's because those guys are first. So if you see the X is first, like on this one, then we know this thing is opening side to side. Over here, if I see the y's first, just like the y-axis goes up and down, this is going to go up and down. And you'll see this axis, which is known as the transverse axis, has your center, your vertices, and foci, and that's going all up and down. Now, if you called that the major axis, that'd be fine with me. Major axis, transverse axis, in my opinion, go side and go together, kind of, right? Because in ellipses, we have a major axis, and it has your center, your vertices, and your foci, and same thing here. Okay, your transverse axis. Okay, has your center, your vertices, and your foci. So, any questions on deciding which way this thing's going? If the x's are first, side to side. If the y's are first, up and down. Okay? Now, when we take a look, we graph that's very similar to when we get ellipses. We'd always want to identify the center. And our center is our h and k value. Just be careful when you grab your h and k. H is always with x and k is always with y. So on this one, you have to look over here. Okay, so if you want the x value, make sure you look at the x's. If you want the y value, make sure you look at the y's, because when the axis is going up and down, it's reversed, so watch out. And again, it's always opposite of what you see in parentheses. So that stuff has not changed since I introduced this stuff here in chapter 1 when we talked about circles, H and K. Okay, it's always opposite of what you see. H is with X, K is with Y. A is the first guy, and A is from the center to those vertices. So that's a distance of A. Okay? So center to those vertices. Your B value is always the second guy. If it's underneath Y, we go up and down B. And then we use that A and B value to make what we call the fundamental rectangle. The fundamental rectangle allows us to come up with these asymptotes, okay, which will go corner to corner through this rectangle. So what I'll say is A and B, we use, so A and B, we use for that fundamental rectangle, which again we use for those lines that your graph gets closer and closer to but never touches, which are known as, when your graph gets closer and closer, these guys never touch it. Watch your mouth. Asymptotes. Hey, can you watch your language over here? Watch your asymptotes. Asymptotes. Hyperbolas. You want to switch? Exact same thing. I knew that, brother. He's teaching the exact same thing in HBC. All right. So we got asymptotes for A and B value. Okay. Last but not least, guys, look at your C value. Look at your formula. That's a formula we've seen before. What is that? P says A squared plus B squared equals C squared, or do they have a written C squared equals A squared plus B squared? Okay. So again, that's your C value. And C is always from the center to the old foci. Okay. Your foci will always be in your bowls. I'm not giving you those silly analogies where you have your breakfast bowl, and in your breakfast bowl, your parabola, your hyperbola in this case, is your Fruit Loops, your foci is in the bowl. Okay? C is always the biggest guy, so that's always going to make sure it's in the bowl. Okay? Do you guys have any questions? So you start graphing these things, you're like, man, this is very similar to ellipses, but it's different. Same thing, but different. So let's get started. Okay? We got everything written down? All right, so let's do it, huh? We got 5 examples. Go through these pretty quick. You can do it, girl. This is your last set of notes. You should be excited. Last set of notes. Here we go. Y squared over I minus x squared over 16 is equal to 1. We want our center. We want our vertices. We want the old foci. Okay. Should I zoom in? Can you guys, let me see if I can zoom in one more. How's that? Better? Good? Too much? I think that's too much. There, that's good. All right, center. H and K. H is with X, K is with Y. I don't see anything, right? 0, 0. The other thing I want to do is identify which way am I going. Is this thing going side to side or up and down, Nick? Up and down, why? Because of the Y first. Yes, sir. Y's are first. So I know this thing's going up and down. So Y's are first, that thing's going up and down. So as I take a look, here's my center. A. A is not the biggest guy. A is the first guy. This is a squared. This is b squared. So I gave you one right away where you see a is smaller than b, right? So if a squared is 9, square root that, and we get 3. So because it's underneath the y's, we go, like Nick said, up and down. 1, 2, 3. 1, 2, 3. And there's my major vertices. And that is up and down 0, comma, plus or minus 3. But b squared is 16, so what's b? Square root that, you get 4. So from your center, it's underneath the x's, so we go 1, 2, 3, 4 to the right and left, 1, 2, 3, 4. And now instead of making an ellipse, like we did with ellipses in the last section, now we make a rectangle. We extend these points until they hit each other. When I do this, I always use a different color, because it's really not part of the graph, it's how we come up with the graph. Okay, always make a dashed or dotted line, just extending those points side to side. And now, asymptotes go through the center, corner to corner. Okay, corner to corner. Okay. And now I've got enough to graph this thing, right? I've got my center, my vertices, I've got my asymptotes. So now I'm just making little balls, getting closer and closer to these asymptotes, nice and long. Little hyperbolas. A little bit wider, a little bit straighter than a parabola. And there we go. Last but not least, we need our c value, right? So we go off to the side and we do our c squared. C squared equals a squared plus b squared. We add the 2 up. So we go back up here, don't take 3 and 4, take 9 and 16 and add those up. So 9 plus 16 is 25, and then we square root that. Again, I'm showing a lot of work. Usually I just do this in my head, and you can too. That's probably fine. I don't need to see this work, guys. I know you're smart enough, you don't need to do that. Okay, so yeah, I'm just doing it for notes so you can see what I'm doing. So C is 5. So follow that transverse axis. We went up and down for our vertices. We got to go up and down for our foci. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So now that vertices are 0 to negative 3, and this foci is 0, comma, plus or minus 5. So now I've got my center, I got my 2 vertices, my 2 foci, I've got everything graphed and labeled. On my transverse axis, which is the line x equals 0, so that all the x's are the same, and we're good to go. Any questions, y'all? Not too bad. If you can do ellipses, you can do this. There's just little different rules that you got to follow. Instead of making circular shapes, we're making rectangles. Okay. No, if you're sitting next door, yes. If you're an HBC, yes. That's the one cell difference. We're not doing that. Okay? Good question. Dirty mouth. Asymptotes. Language. All right, next one. Sorry. Next one. I've got 9x squared minus 4y squared equals 36. So we take a look. We always want equal to 1. So what do we got to do? Divide everything by 36. Our, go ahead and reduce, you pirates. Our 936 reduces to x squared over 4 minus 4 over 36 is minus y squared over 9, and then equals 1. You guys okay with that? With that, I know my center. I know those vertices. And I know the foci. Center, h and k. H is with x, k is with y. Don't see any parentheses, so it's 0, 0. Okay, and I also know which way this thing's going. So somebody with a hand up. I don't want to hear the same people. Hey, what do you say?
side to side. Awesome. And that's because the x's are first. Very good. I got 0, 0. Now I need my A and my B. A, B, C. A is not the biggest guy. It could be. But it's always, for hyperbolas, it's always the first guy. So this is A squared this time. This is B squared. So if I take a look, A squared is 4, square root it. You get 2. So I go over 2, 1, 2. 1, 2. And there's my vertices. So I go ahead and label those. So on left and right 2, so plus or minus 2, 0. And now I do my B value. Take this B squared equal 9, square root it, and we get 3. Square root of 9 is 3. We go up and down. 1, 2, 3, and down. 1, 2, 3. Now, back in the day, we would do a circle with ellipses. Now we're doing a rectangle. We just extend each point side to side. And then we go corner to corner, right through it. The idea here is this is really how we come up with the slope. We use our A and B value. The idea is the slope is up your B value over your A value. But again, you don't need to come up with those equations. I have enough. Katie said that this is going left and right, so now I just start at my vertex. And I go this way towards my asymptotes, side to side. I always graph those guys first before I do the foci because every once in a while I'll get people that find the foci and then start your hyperbola, from the foci. So actually graph it from the foci instead of the vertices. That's crazy, right? The foci goes in the ball, it's not the start of your ball. The foci is your Fruit Loops, right? Bless you. C, B squared equals A squared plus B squared. Go down here and add these up. 4 plus 9 is 13. Square root of it. We get the square root of 13, which is about what? As a decimal. Square root of 13? 3.6-ish? Right about? So we're going to go again on that transverse axis, that major axis. The x's are first, so we go left and right. 3.6-ish. 1, 2, 3.6-ish. 1, 2, 3.6-ish. And that is plus or minus root 13 comma 0 is what I want. We want exact values when you're all said and done. We do not want decimals. Oh man. We have one over there. Right there. Oh, here we go. Turn off this. You guys see it? No way. Oh, yeah. Oh, man. Watch your mouth. Captain America always says language. Alright. That's crazy, right? So right next to the wall, what do you have? Hyperbolas. Never saw that before, did you? Oh man. It's in the PowerPoint slide I'm going to show you Monday. Alright, ladies and gentlemen, let's finish up example 3.5. We got about 20 minutes left. Center 0, 0. Now we're going to switch gears here. Now we're going to give you a little information. And now we got to come up with, it says find the equation, and then we're going to graph this thing. I think we're all pretty much visual people. We need to see this out on a graph paper to see it. So let's go ahead and do that. I'm going to go ahead and graph my center. Okay, so that's C, my center. And I'm going to do my focus. My focus is 0, -6. So again, that's down. 1, 2, 3, 4, 5, 6. And with that information, I know A, C value, so I know C is 6. So I know the other focus is at 0, 6. Just go up the other direction. 1, 2, 3, 4, 5, and 6. Very good. Alright, so same idea. I got my vertex now is 0, 4. 1, 2, 3, 4. So that means the other one's at 0, negative 4. 1, 2, 3, and 4. Alright, so I got those guys. And I know A. What's A? 4. Perfect. So now I know a lot here. Because I'm going up and down on the y-axis, I know who's first. Who's first? The y's are first, so I know this is y squared minus x squared equal 1. There is no h and k because my center is 0, 0, right? So it's x minus 0, which is just x, and then squared. 1 minus 0, which is just y squared. I also know a squared is first. So I know a squared goes here. A squared is 4 squared, which is 16 goes here. Guys good with that? The problem is, with my equation, I don't know b squared, the second guy. That's what I got to find. Okay? So, how do I do that? I use my little p-tags, right? C squared equals a squared plus b squared. Again, if this is a minus and this is a plus for hyperbola. And sometimes people will show you, hey, if you want b squared, you can do this. Just subtract the a squared over, take c squared and minus a squared. Or if you want a squared, take c squared minus b squared. So you can use those formulas if you want. That's just confusing for some people, so I usually don't talk about that. I might do it over HPC though. Alright, so just plug these guys in. C is 6, so 6 squared is 36. A is 4, so a squared is 16. And then plus b squared. So we can go ahead and subtract that over. 36 minus 16 is 20 for b squared. So 20 is b squared, that goes here. You guys good with that? So I'm going to go ahead and just finish the graph. I'm going to square root this guy. I get the square root of 20. Just for fun, let's practice simplifying roots. Don't really need to do it here, but just so you can see it. 4 and 5, 2 and 2. This is 2 root 5. Again, the square root of 20, 2 root 5. That's about what? 4 something? 4.5-ish? Something like that. So for graphing, is that right? About 4.5? It's a little bit more than the square root of 16, but under the square root of 25. So I'm going to go over 1, 2, 3, 4 and a half or so. 1, 2, 3, 4 and a half. Asymptote, start at your vertices. Make a rectangle for asymptotes. Asymptotes are corner to corner. Through the center. And we got this thing up and down because that transverse axis, that major axis, is all up and down. There we go. Good stuff. Not too bad. We got our C value. Just have any questions? Alright.
So recording my lectures yourself and I'll explain it.
No, you're not.
No, yeah. The same lesson and then it does. I don't know.
Somebody just let them watch it.
Xing Shai.
Shang-Chi. Oh, man. People at home are like, what is going on over there? Alright, let's finish up example 25. We got 15 minutes, so let's get it up. Find the center of the foci. In the vertices of each hyperbola. Now we're going to start moving these things around. Now we're going to look at vertical 3. If you can do what we just said, this is going to be pretty easy. I promise, kids. gives me minus x plus 2 quantity squared, and then equal 1. Now, if you want to, you can put a 1 over there, and I usually do so that I can see my A's and B's. Okay? Guys have any questions of that? Alright, so I need my A, I need my B, I need my C. And I'm going to bring this up so I can write my center. Those vertices in the old foci. Now, this is where we got to be careful. H and K. H is X, K is Y, opposite of what you see. So let's get a hand up. Who thinks they know who the center is? What's our center? What's our H and K? Matty Burns, what do you got? Close. So H. Awesome. Awesome. Good job. So -2, if you want the X value, make sure you look here. So opposite of what you see, now you said -2, and you have Y minus 2, that's positive 2 for the Y. Perfect. So I take a look, I got -2, 2, 1, 2, up 1, 2. And I also like to know which way this thing's going for the A value. So Ryan, which way is this thing going?
Wouldn't it be going to the,
Who's first?
oh, I have to be going up now.
So first are the Y's. If the Y's are first, then I got this thing going up and down. That allows me to find the A value. A is always the first guy, B is always the second. Okay? A is not always the biggest, it just happens to be the biggest on this one. So A squared is 4, so that means A is what? 2? Square root it. So because the Y's are first, I'm going to go up and down 2. 1, 2, 1, 2. And now I want that in vertices. So from the origin, I count over 1, 2, that's -2, 0. Okay? Yesterday on the quiz, I was getting weird answers for vertices. I had -2, 2, and then plus or minus 2. You need to simplify that. Okay, so -2, 0. And then over to up 4, -2, 4. We go okay with that? Any questions? But B. Take this guy's square root of 1. So I just go left and right, it's underneath the x's. And now look at that little rectangle right there in quadrant 2. Asymptotes, corner to corner. So we use our vertices, that's where we start our hyperbola towards the asymptotes. And again, you guys should have arrows on the ends here. So that I know that you know that you know that I know that I know that you know that it goes on forever and ever. Little arrows. Yes, sir?
For the center, why didn't you, do the opposite?
I did. So H is with X. So this is H. And this is K. But we gotta be careful. Number 1, do the opposite, and then also make sure you grab the X, the H with the X, the K's with the Y. So good question. Good job. Last but not least is your foci. Come back down here and add these two up. So C squared equals A squared plus B squared, which is 4, plus 1, which is 5. You square root it. We get the square root of 5. The square root of 5, guys, is like 2.1-ish or so. Something like that. 2-ish. So we're like pretty stinking close to those foci. Really close to those vertices. Now, how do you write that? I'm at my center, -2, 2. I always look to see what just changed with my vertices. The x's stayed the same, it's the y's that changed. So that's what I add and subtract to. So I take that C value and add and subtract to the center's K value. So my final answer is -2, 2 plus or minus root 5. That's what I'm looking for that. Okay, you guys have any questions? So again, my center, so you guys can see this Did I see it all right? Any questions? All right, let's finish up. Last question on the last set of notes for 2021, baby. Yeah? Let's do it. First question I like to ask is, what are we graphing, and how do you know? This is hyperbola. Obviously, we're doing hyperbola notes. How do you know? Because this is one of the questions on your final exam or your replacement test. How do you know that this is not a parabola? Right. So you could complete the square, but you can even tell right away. So let's kind of work through why do we know it's, so it's a good guess, but why do we know this is not a parabola? Is my question. Right. So it's definitely not an ellipse because there's subtraction here. So if I have something squared minus something squared, that has to be hyperbola. There's not an ellipse here. If it was something squared plus something squared, we would have an ellipse. So that's good.
Does it have to do with the negative one because before we were minusing?
No. There's nothing to do with the negative one. What do you guys know about the formula for parabolas? That's a good guess. But what do you guys know about formula for parabolas? If you look at your parabola formulas, what do you notice? How many things are squared? How many quantities, Matt?
The y and the x squared were in parabolas.
Yes, the parabola is one thing squared. This thing has two things squared. So if it has two things squared, it can't be a parabola. It's got to be either an ellipse or a hyperbola. And then if it's a plus, then that's an ellipse. If it's in a minus, then it's a hyperbola. So that's all good stuff right there. That's a question you're going to see. So be aware of it. Awesome. So let's graph this thing. We're going to go ahead and add the 1 over. I would like to get that guy out of the way. And I'm going to group my x's together. So I've got x squared minus 2x. And then I got this negative y squared minus 2y. And I've added the 1 over, so that's plus 1 on that side. Now again, we want to get quantity squared, so we got to complete the square, but we can't do it with this guy yet. And the reason why we can't is because there's a negative here. We got to get rid of that number in front. We got to get rid of that negative. The only way to do that is to take out and factor out the GCF. So rewrite this guy. Leave some room. I'm going to take out a negative here. And now I've got y squared plus 2y. I've taken the negative from here and in from here and took it out to the front. So if I was to distribute, that would give me this, that would give me that. And I've lost some room in there. Now I'm ready to complete the square. I'm going to take my b and I'm going to divide by 2 and square it. Alright, so let me highlight my b's. Here's my b here, here's my b here. I'm going to take b, divide by 2 and square it. I'm going to take negative 2, divide by 2 and square it. What is that? It's 1. Whoa! If you add it to one side, you got to do it to the other. So if you can tell, I'm using a green 1 there. Then I got to do over here. I got to take this 2, divide it by 2, which is 1, and 1 squared is 1. I'm going to add 1 on the inside. But if I do it on the inside, I got to think of what did I really add over there so I can put it over here. Because there's a negative here, what did I put over here? This has got to be negative 1 times 1 and negative 1. So I've got to take this times this to put it over here. On that side of the equal sign. Does that make sense? Any questions why I put negative 1 on the right? Well, now we factor. When I factor, I should get a quantity squared minus a quantity squared, and then 1 plus 1 minus 1 is 1. Okay, so I factor. Factors of this green one that adds to negative 2, if you don't know those factors, just divide the yellow guy by 2. That's negative 2 divided by 2. Negative So with those guys, I get 1 for A, and that's underneath the x's, so I'm going to go left and right 1 for the vertex. So this point right here, just from the origin, is down 1, so that's 0, negative 1. And this is over 1, 2, down 1, so that's 2, negative 1. You guys okay with those vertices? Alright, so my B is underneath the y, so I'm going to go up and down 1. And I actually make a nice little square. Sometimes rectangles are squares, and that's okay. Sometimes A and B are the same for hyperbola, that's okay. Sometimes A is bigger, sometimes B is bigger. That's okay. Just know that A is always first. Because the x's are first, the transverse axis is going side to side, which means my vertices, my center, and eventually my foci are going side to side. So this graph is going side to side. Last thing I need is my C value. So I take a look. C squared is equal to A squared plus B squared. Come down here. That's 1 plus 1, which is 2 for C squared. I square root it, so I should get the square root of 2. The square root of 2, guys, is about 1.41 or so. So I'm going to go over 1.41-ish, over 1.41-ish for the foci there. Pretty darn close to those vertices. Now the tricky part is coming up with the foci. So start at your center, and then I always look to see what's changing from the center to your vertices. I see that the x values have changed, and that's because I'm going left and right. That means I gotta change that value right there. So my final answer here is 1 plus or minus root 2, comma negative 1. And that is what I'm looking for. Okay, so let me zoom in now on the graph so you can see that good. Okay. That's my nice pretty graph. So ladies and gentlemen, out of a 10-point scale on the OMG, oh my gosh scale, that's probably an 8. That's an 8 or a 9. That's a difficult problem. But if you practice enough, you'll get it. It won't be that hard. Okay? Ladies and gentlemen, we are all done with my purpose. That was our last set of notes for 2021, baby. Nice job. You guys have a great day.